Today is April 23rd. We're going to talk about the discriminant today.
Discrimination.
Exactly what you guys are doing right now. All right, the discriminant. So this is a specific formula. The discriminant, and we'll write it like this, D, which will stand for discriminant, is equal to b squared minus 4ac. What this will do, it'll let you know how many roots or how many x-intercepts a parabola has. So for instance, let's say we sketch a quick graph here. We have, in blue, these are parabolas that have no roots.
Yeah.
And what they are is a vertex that's either above the x-axis facing upwards or a vertex below facing downwards.
Sir, what if it intercepts the y?
So, another option we have are the red ones. These parabolas will have one x-intercept. Okay? And that's when the vertex is directly on the x-intercept. And finally, our green options have two x-intercepts, which are we're most used to using, and they cross. Okay? Now we're going to write the formulas for each of these. They still use the same discriminant. The only difference here is our blue is when b squared minus 4ac is less than 0. Or in other words, you get a negative number. If you get a negative number when you plug these in, when you plug numbers in for these variables, you're going to have no x-intercepts. In other words, parabolas above or below. No real roots is another way to say it. When b squared minus 4ac is equal to 0, that means we're dealing with parabolas that have their vertex directly on the x-axis. And finally, when b squared minus 4ac is greater than 0, that means we have two roots, or a parabola that crosses the x-axis two different times. Now you might be going, what is A, B, and C talking about? They're talking about quadratics that are in standard form. Okay? So we have our standard form here. In order to use the discriminant, we need to have our equation in standard form. Our A is the coefficient in front of x squared, our B is the coefficient in front of x, and our C is the constant term. Okay? So we'll take values of those, plug them into this formula here, and depending on whether we get a positive number, a negative number, I should write that below, or a number equal to 0, will tell us exactly how many roots there are. So instead of going through the whole process of factoring or putting something into the quadratic formula, we can do this if we just need to figure out how many times something crosses the x-intercept. Now, the reason this works so well is because of the quadratic formula. It's actually a piece of it, if you notice. So I'm going to bring that part in. So our quadratic formula, if you notice, actually includes a discriminant in it. It's underneath the square root sign, b squared minus 4ac, which is exactly our formula here. Now, the reason these make sense, I want you to think back of when you've actually used the quadratic formula. If you get a number less than 0 or negative, am I able to continue with the quadratic formula? No. So that means I have no roots, right? We're unable to find any of them.
Why?
Because we can't square root a negative number. Right? If we get 0, 0 replaces that, and here's a quick example. Let's say we had negative 10 plus or minus the root of 0 divided by 2. Okay? The square root of 0 is 0, so when we go to split this equation, I get negative 10 plus 0 divided by 2, or I get negative 10 minus 0 divided by 2. Am I going to get different answers when I solve these?
Yeah.
No. I'm going to get negative 10 divided by 2, negative 5, and I'm going to get negative 10 divided by 2, which is negative 5. So again, only one root, the x-intercept.
So if they're same, it's only one root?
Yeah. So again, those numbers are completely made up. That was just an example, okay? I just made those numbers up. They're not actually a part of what we're doing right here, so we'll kind of put them to the side. And finally, if we do get a number greater than 0 or a positive number, when we find the square root, we're going to get two different terms when we go to split it. A positive and a negative, which means we'll have two roots. That's the idea behind this. So this discriminant tells us exactly how many x-intercepts a parabola will have, depending on what number b squared minus 4ac equates to. I've written them down here on our formula page. Okay? b squared minus 4ac greater than 0, there are 2 roots. When it's equal to 0, there's 1 root. And when it's less than 0 or negative, there are no. Okay, example. We have an equation here, and I need you guys to recognize that it's in standard form. Okay? So, because this is in standard form, we can easily figure out what A, B, and C stand for, and therefore we can put it into our discriminant. Our A term will be -2, the B term, -3, and the C term is -5. Now remember our discriminant formula, our D. So our discriminant is equal to.
So, this is the b squared minus 4ac.
Exactly what it's equal to. So we're going to plug numbers in for that. Our B is -3. Our discriminant is equal to -3 squared minus 4 times -2
Negative 2 bracket.
times -5. So I want you guys to look at this. -3 squared is going to give us 9. When you're multiplying this, think of this as the term -4. -4 times -2 gives us +8. And +8 times -5 will give us -40. So we're multiplying. That's the formula. 4 times A times C. So 9 subtract 40 gives us -31. We have a negative term. Therefore, how many roots are there? There are no roots. This is less than 0. Now let's say I change this equation just a little. -2x squared minus 3x plus 5 equals 0.
Yeah. It won't touch an x.
Times another negative.
See, because I always thought you'd do negative.
So I've changed it just a little. We still have -3 as our B squared minus 4 times A, which is -2. And the only difference here is 5 is now a positive term. What that's going to do is just change our 40. We're still going to get 9. -4 times -2 is +8.
Sir, but why does the 5 change?
I just made a different question.
Oh, it's a
Keep up, keep up. And then that becomes +40. We get +49. How many roots?
2.
2 roots. Okay?
So give us an
And this
example.
one has 0 roots.
Sure, give us an example of a bracket negative 9 over 8.
How did I do what?
Yeah, how'd you get 9? Because I don't know. I'm not following you.
8 times -9 over 8. Is
So you
9.
do 8 times -9 and then 8 times
So, sir,
8.
can you
No,
draw
8
zero
times -9 divided by 8.
Oh, okay.
Sir, how would you draw 0 roots again? I remember you cut it out. Yeah.
Red ones. Yeah.
Okay.
You know how you put that 1 underneath the 8? Like what happens if you just multiply it through? Like we didn't like.
Straight across. So what is 9? What's 8 times 9?
72.
72 divided by 8?
8. I mean 9.
9.
So we still get the same answer.
Still get the same answer. I just knew the answer would be that.
Sure, one more time.
Would it work for like any other question?
So when you're dealing with fractions, you did 8 times -9, and whatever that was, you divided by 8.
Yo,
Yeah.
Ben. Say ball sacks noodle.
Are you recording?
No.
Okay, good.
Thank God.
Thank God.
Okay.
That would have been embarrassing.
Now, I gave you guys questions 1 to 7 to do on
In
this.
the blue book? But in blue book it says 4, 10, 12. Sorry, I actually need a blue book.
4, 10, 12, and what?
Yo.
13. So for today, you should have done your 1 to 7 already.
Darts.
You're gonna play.
10,
You
12,
guys know how to
13.
play?
I want you guys to do 8, 9, 10, 12, and 13.
8, 9, 10.
With my piece? I don't even know. I think I threw it out like.
After class, remember before it said, oh, give a quarter?
I don't know where it went. A what? A quarter?
Yeah, we're like, Oh, yo, I know, we can use cake.
That's again.
Yeah, but it's not that sticky. Sir, see our game that we made on
Yeah,
Friday?
why do you need it?
We made a game.
Sure, we played darts on Friday. James versus Benedict.
It's actually educational because you have to add it up, right? Look, see the math?
Yeah, and
So you gotta do basic grade 3 math?
Yeah.
Youth. It's not gonna work.
Wait, what was?
It's not.
We had class 13, and if it's
Play.
stuck, Yeah, it's like dark. Like,
And I won.
Yeah, I think one.
I won.
I didn't get it. Yo, where did you get it?
Huh?
Where did you get it?
He got exactly 250.
Yeah, you have to
got
get exactly
260.
Yeah, Fonse,
That
what
day
up?
got 220.
Yes, a baby.
Fonse was here?
You
No,
couldn't
no,
go
no.
some first goal.
Oh.
It's like darts. It's like darts.
You go over 50, dude.
Yeah.
If you go over 250, you go back to 0.
Yo, Jade, you didn't do 10 push-ups.
Yeah, Jade, what the heck?
I didn't lose though.
Yeah, you lost the
Yeah,
best.
Jade, you
I
lost.
went back to 0, but I didn't lose.
I found 50.
Yeah, you both.
Oh, really? Did you?
Yeah.
Yo, I didn't see that.
Oh, my bladder.
Sorry,
Sorry.
exciting game.
Yeah, I had 90 zeros too.
Wait, no.
They're like the soccer idea.
Did you? There's a soccer version?
I know.
That's it?
Are these supposed to be like light?
Yeah, they are.
Yeah, same with the soccer ones.
But that's what she was cooking there too. I seen them downtown this year. It was in the newer version.
Are those ones? Oh, with the tags?
Yeah. I think it's in
You
the
guys
newer.
wanted to play last time.
So where'd you get those? Nike store downtown?
No, I got them for free.
Yeah.
Same. Same.
Got them from Coach's Clinic. Nike puts on. Give me shoes.
What do you call it?
Supposed to be cross country. I told them I'm like, yeah, I coach cross country. And they give me free shoes.
Yeah.
Those guys.
And they ask you your size and everything? Like,
Yep.
Wow. It's nice.
Can I help you?
No, nothing.
Sometimes when you're at certain basketball team, they give you free basketball shoes.
So, can you talk the
Sir.
What's that?
But I
Can you
love
put the stuff that we did right now for
cheap
reference? Like in
The
the
soccer.
I don't pay
Yeah. Oh yeah. I'll leave it up on the board. Yeah.
But soccer fee would be 250.
Seriously?
Discriminant,
How do you know if it has 0 roots or 2? I would
How do you know if there's what? Say it again.
like roots or not.
I should have stopped playing.
Positive. It's got 2 roots.
If there's
Yeah.
a negative, it's 0 roots. If it's a positive, it's more.
We're gonna have to like argue. That's so far.
Okay.
Oh, yeah.
Here is a more difficult type question. I want you guys to take a look at.
Ah, thank you, sir.
Oh, shut up. Real roots?
What's the K? Is that a K?
This is the
Is
K.
it what? Isn't it what? K.
We're gonna talk about this. You guys ready?
Sure, because
Okay. So we've been given this equation, and they want to know for what value of K is there 1 root, 2 distinct roots, and no real roots. Now, in order to use a discriminant, we need to be in standard form.
We are in standard.
so I know what to do.
But in order to be in standard form, we need to be equal to 0. So we're taking this equation. I need to move the 5x squared.
Oh.
This comes negative.
Sorry, that's not supposed to be squared.
So yeah, once you move
The 5x squared to the other side of the
It
equation.
comes negative.
So we get negative 5x squared plus kx minus 10 is equal to 0. We can now use our discriminant and the values. Now remember, we put down here what the values would be, b squared. Okay, so we're in standard form, so we can use our discriminant. Now remember our rules to discriminant. What we're going to do is we're going to find for the very first one, for 1 root, that means we need it to be equal to 0, the discriminant.
Yeah.
So 0 will be equal to b squared minus 4ac. Okay? Now our values. A is negative 5. B is our k. So I'm going to replace b with k minus 4 times negative 5. And c is negative 10.
K is 1.
Right now we're going to work on k. K
Why?
squared.
Why is K squared?
Now, because we replaced the b with k. We replaced this b with the k term. Negative 4 times negative 5 is positive 20. Positive 20 times negative 10 is negative 200. We've got here.
You take the other side and
Nah, that's wrong.
yeah.
What'd you ask?
So, 0 is equal to k squared minus 200. I could solve for what values of k. When I moved 200 to the other side of the equation, it will become positive 200 is k squared. And in order to find out my values of k, I'm going to square root both sides.
40. No, it's not 40. It's 40.
So, square root of 200, well, no, it won't be 40.
You so paranoid.
200 square root is 14.14, we'll say. But, is there only one answer to that when I square root 200? I have plus or minus 14.14. So there are 2 values of k. If this was either positive 14.14 or negative 14.14, that's all rounded, we would have 0 roots in this question. Now, that was only for the first one. That was for one root. 2 distinct roots, what is the rule?
More than one.
More than one, okay? So in other words, let's go right back to this point again, because these numbers are all going to be the exact same. But in this case, it's no longer equal to 0. It needs to be greater than 0. Squared minus 200, okay? So in other words, again, to find out, we bring 200 to the other side. We get 200 greater than k squared, okay? We square root both numbers, and we get plus or minus 14.14. Okay, so in order for this to work, I want you to think of the idea, values of k. We need our values of k on a number line, and it's going to look like this. The values need to be either, and this is an absolute value, they need to be greater than 14.14 to create a positive number, or they have to be less than negative 14.14 to create a positive number that's larger than 200. That's the idea behind this. Okay? So there's actually 2 different values here because we're going for any number. If we plugged 15 in, 15 squared would have made a number larger than 200, and we would have had a positive number. Or negative 15 squared would again made a number larger than 200. But if we put something, if we put something like the number 10, which falls between negative and positive 14, the number 10 would have only made 100, and we would have ended up with a negative number. Okay? So because we now know what positive numbers there are, we can actually figure out from this information what terms would make no real roots. And that will be any term between negative 14 and positive 14. So if I plug any number in that range, say it was 3.3, and we square 3.3, we're definitely going to get a number less than 200, which will give us a number that is less than 0.
So wait, if you plug in